Welcome to the next module where we're going to be looking at using data, standard deviations and looking at means. Why are those numbers so useful to us? Well, with those numbers we can start to look at how does our process work. We might want to know, are we on the middle? Are we at the top? Are we at the bottom? How much variation have I got in my process? What does this sample that I've taken look like compared to the population? So to give this study on standard deviation and mean a little bit of gravitas, let's go shopping. Let's just say, for example, we're on a mission to go and buy some cheese, and we've gone to the cut counter to buy cheese, and what we found is a piece of cheese which is coming at 235 grams. The question we want to ask is that in the middle of the distributions of cheese that are available to me to buy? Is it at the top? Is it at the bottom? What would be the heaviest piece of cheese that I could buy on the shelf? And from this piece of cheese what would be the lightest piece of cheese that I could buy? So to do that, the first thing I need to do is have a quick look on the shelf to identify where are the cheeses currently sitting. So I've taken 15 samples of cheese. What we can see here on these 15 samples of cheese is a series of numbers. From those numbers I can calculate the mean. Now we know the mean already because we've seen it in this module. The mean is simply add the numbers together and divide by the number of numbers. It is a way of giving us a central value. It's a way of saying all the numbers, all the things that we're collecting are figured around this one value. But that in itself doesn't tell us what's the heaviest, what's the smallest. All it does is it tells us this is the central value. If we want to look at the spread of the data, now we need the standard deviation. If we calculate the standard deviation, we first need the mean. And the mean has told us we are 230.2 grams. That is the average weight, the mean weight of our products. But the standard deviation, that comes in at 3.57 grams. 3.57 grams. That's a really important number because you see standard deviation is in exactly the same values that we have measured our product in. So now with a standard deviation I can talk about variance in terms of spread because I have a value that relates to what I've measured. So the question now is, what would be my maximum weight? What would be my minimum weight? What would be my typical weight, my average weight? And my 235 gram piece of cheese, where does that fit within this process? Well, first of all, we need to understand the standard deviation and what that means. As we've seen earlier in the model, the standard deviation is the point of inflection on the curve. That's great, because that tells us when we're talking about one standard deviation, we imply plus or minus. Between -1 standard deviation and +1 standard deviation, we have 68% of our data sitting between those 2 points. When we increase it to plus or minus 2 standard deviation, that then increases to 97%. And when we go to 3 standard deviations, it becomes 99%. So I can now talk about the spread of my data in terms of 99% of what I would see in terms of plus or minus 3 standard deviations. So let's get rid of the standard deviation and replace it now with 3.57 grams. So either side of the mean for every standard deviation increment, which we can see is an equal distance, we can now have 3.57 grams. When we put these together as cumulative numbers, what we now find is my minimum weight is 219.45 grams. My maximum weight is 240.91 grams. My question was, what's my minimum? What's my maximum? What would I find on the shelf? Well, there's the first part of my answer. My second one is the sample that I have bought. Where does it sit? It sits between 1 and 2 standard deviations. It sits at 235 grams. Now I'm able to tell you where the mean sits, the sample that I've got, and I can tell you the spread of typical values. Well, that's great if we're buying cheese, but what about the real world? Why would we ever want to do this in our world? Well, it's quite straightforward, really. I might be collecting samples and I might want to know, based on a dimension, what is the typical spread that I could expect to see, plus or minus 3 standard deviations, from a sample set of data. I might want to look at how much material we're using to make that product. I might want to look at the shot weight that we're using to form the plastic bottle. I might be wanting to look at the material rheology, the processing variation, the fill volumes, all sorts of things. I might want to be able to look at my data and say, how close are we to the mean? And this sample that I have taken, where does it fit on my distribution? Now we're starting to understand why standard deviation is such a useful number, and when we compare it with the mean and the spread, now we can understand what we want to look for. We're going to come back to standard deviation later in the modules when we look at capability, but standard deviation is fundamental to everything we do when we're looking at our process management systems. Hope you've enjoyed this part of the module. We look forward to working with you in other modules and sharing with you how these great tools can help us.